Hello and welcome to Avid Shiksha. This is Crash Course of General Science Part 2. So last class I start with the very basics of chemistry, that is matter, and today our topic of discussion is atom. So class start kora agote okoman edu sailon je ami amar class ot ki topics discuss korim. So today's class overview is number 1, Dalton's atomic theory. First of all, edu koilao je Dalton's atomic theory ami pohi kyo asu. Although our topic of discussion is atom, but atom start kora agote we need to study about Dalton's atomic theory, because this theory provides us with a nice base, bhal base eta provide kore, bhal starting point eta provide kore to better understand atom. So atom start kora agote we will be shortly discussing about Dalton's atomic theory. Then we have atom. Number 3, subatomic particles. Number 4, energy levels or electron shells. Number 5, atomic number, mass number and number of neutrons. Number 6, isotopes, isobars and isotones. Number 7, atom, molecules and ions. And number 8, we will be studying about electronic configuration, valence electrons and valency. So start korisu with John Dalton. Who is John Dalton? John Dalton was an English chemist, physicist and meteorologist who around 1803 was successful in answering many questions related to atoms. So John Dalton 1803 around 1803 তেওঁ কি কৰিছিলে atoms or লগত related many questions or answers দিবলৈ successful হৈছিলে, and he also put forwarded the Dalton's atomic theory. Now what is this Dalton's atomic theory? Under Dalton's atomic theory, we have various postulates. बहुत postulates আছে আৰু এই postulates কিটা কি হয় অকমান চাই যাও বাৰু. So number 1, we have matter is made of very tiny indivisible particles called atom. কৈছে যে matter যোনটো আমি last class already discuss কৰি থৈছো, matter it is made up of tiny particles, and these tiny particles indivisible হয় আৰু আমি divide কৰিব নোৱাৰো. So tiny indivisible particles aru ei particles bilakor naam hoise atom. So matter ok ami jibane divide nokoru kyo, in the very base, in the very core we will find a particle eta pam which is undivisible aru ami divide koribo nwaru aru hekhiniye hoise amar atom. Then number 2, we have atoms can neither be created nor be destroyed in a chemical reaction, meaning amar jodi chemical reaction eta choli ase between carbon and oxygen, then in that chemical reaction carbon aru oxygen or bahire kuno beleg atom ba kuno beleg element or atom create no hobo. Suppose carbon or oxygen or major reaction choli ase, beleg atom for example nitrogen ba phosphorus create no hobo. Similarly carbon or oxygen or major reaction choli ase, so enekwa hobo nware je carbon destroy hoi pele ekebare naikia hoi jabo. So second postulate hoise atoms can neither be created nor be destroyed in a chemical reaction. Number 3, we have atoms of a given chemical elements are identical in mass and in all other properties. Eta elementot jiman atom ase they will all be similar, either mass or kotha koisu ba beleg chemical properties e nokon kyo they will all be similar. Aru number 3 logot number 4 to okoman similarity ase. So number 4 postulate hoise different chemical elements jodi ami beleg chemical elements lo, then they will have different atom aru he different atoms or different mass thakibo and different properties thakibo. Then number 5, we have atoms combine in a ratio of small whole numbers to form compounds. Jodi compounds form kora hoy, then atoms small whole numbers or ratio combine kore. For example water ot hodai duta hydrogen and 1 oxygen combine hoy. Ami ketiao half oxygen na pao ba 3/4 of oxygen combine hoa dekha na pao. Hodai small whole numbers or ratio combine hoy. And then 6th postulate, we have the relative number and kinds of atoms are constant in a given compound. Eta compound dot eta constant number of atoms thakibo, eta constant kind of atom thakibo. Example carbon dioxide dot hodai eta carbon and duta oxygen e thakibo. Carbon monoxide dot hodai eta carbon and eta oxygen e thakibo. So the number of atoms and the kinds of atoms are constant. So from Dalton's atomic theory ami dhuniya koi atom or eta definition uliabo paru je atoms are the building blocks of matter, they are the basic unit of an element. Building blocks of matter hoy and basic unit of an element hoy. They are very small and indivisible, bahut horu hoy and indivisible hoy. The point that atoms are indivisible. Dalton in 1803 কৈছিলে যে atoms are indivisible. But 1803 পিছত many new and improved atomic theories were put forward. আৰু বহুত বেলেগ বেলেগ সাইন্টিস্টে বহুত বেলেগ বেলেগ theories, বহুত improved theories put forward কৰিলে and তাৰ পিছত আমি গম পালো যে atoms they are in fact divisible and we can divide atoms into 3 subatomic particles. So এইখিনিতে আমি ক'ব পাৰো যে Dalton in 1803 Dalton's atomic theory যিখিনি postulates put forward কৰিছিলে not all the postulates are not completely true 100% সঁচা নহয়. That is why Dalton's atomic theory আমি currently accept নকৰো. It is not accepted. But still Dalton's atomic theory পঢ়াটো important হয় because it gives us a nice starting point. ধুনীয়া starting point দিয়ে to understand atom. So atoms are the building blocks of matter. They are small and indivisible. Dalton কৈছিলে, but তাৰ পিছত আমি গম পালো যে atom can in fact be divisible into 3 subatomic particles. Now what are these 3 subatomic particles? Subatomic particles আমাৰ ওচৰত তিনিটা আছে. First we have neutron, then proton, then electron. So neutrons কি হয়? Neutrons are neutral in charge. Neutral in charge হয়. Neutrons are positive charge না থাকে, negative charge না থাকে. In fact they are chargeless. Neutrally charged হয়, নহলে আমি ক'ব পাৰো যে they are chargeless. They are present in the nucleus of an atom. Atom or nucleus are present থাকে. What is a nucleus? Nucleus is centrally located. Atom or একেবাৰে centered present থাকে and it is a small heavy spherical region. সৰু heavy spherical region এটা হয় which is centrally located in an atom and in this nucleus আমি পাও neutrons. Neutrons are discovered by James Chadwick in 1932. Number 2 we have protons. Protons are positively charged. Neutrons jenekoi charge nasile neutrons are. So protons have a positive charge and they are present in the nucleus along with neutrons. So the neutrons are logot ekeloge nucleus are present thake. Protons make the nucleus positive. Ami second point ot gom palu je nucleus ot neutrons ho thake, protons ho thake. Since neutrons are chargeless and protons are positive, that is why nucleus is positively charged. নহলে আমি এনেকৈ ক'ব পাৰো যে nucleus positively charged এই কাৰণে হয় because protons are present there. Protons they are discovered by Ernest Rutherford in 1911. এহিন্দে এটা কথা কৈ থওঁ যে actually in 1898 Goldstein নামৰ scientist এজনে discover কৰিছিলে positive particles in an atom. But Goldstein অকল positive particles আছে বুলি কৈছিলে. He did not say that these are protons. So a same positive particles in the year 1911 Rutherford name কৰিলে as protons. So যদি অপশনত দুইজন সাইন্টিষ্টৰ নাম থাকে then আমি ক'ব লাগিব যে 1898 ত Goldstein discovered positive particles. But in 1911 Rutherford named these positive particles as protons. Then we have electrons. Electrons are negatively charged. Protons are jeneko positive charge thake, similarly electrons are negative charge thaibo. And they are present in energy levels or electron shells around the nucleus. Protons are neutrons nucleus are present thake, but electrons nucleus are akhe pakhe kisuman circular path thake and these circular paths are known as energy levels, nohole electron shells, nohole ami orbits boli ukor. So electrons revolve around these orbits. Electrons and protons together they make an atom neutral. Jiman proton thakibo neutral atom etat himane electrons thakibo aru positive negative cancel hoi pele an atom becomes neutral. It is discovered by J.J. Thomson in the year 1897. Now since ami energy level or electron shells so point eta paisilo ehinte so okoman janilo je energy levels electron shells nohole orbits nu ki hoy. So these are circular path around the nucleus where electron revolve. Nucleus or akhe bakhe eta circular path ase where electrons revolve. The energy of each shell is constant. A energy shells by electron shells or energy hoday constant thakibo and the numbering is from nucleus outwards. নিউক্লিয়াছৰ পৰা আমি যিমান আউটৱাৰ্ডছ যাম নাম্বাৰিংটো তেনেকৈ হৈ গৈ থাকিব ফৰ এক্সাম্পল নিউক্লিয়াছৰ the ring or the orbit closest to the nucleus is numbered as 1 and tar naam hoise k tar next orbit to number kora hoise as 2 and naam to hobo l tar next hobo 3 and the name will be m and it will go on numbering o teneko go thakibo naming o teneko go thakibo. The next point we have greater the distance of the orbit from the nucleus greater is the energy associated. Ami নিউক্লিয়াছৰ পৰা যিমান দূৰলৈ গৈ থাকিম অৰবিট যিমানে দূৰত থাকিব দি এনাৰ্জি অফ দ্যাট অৰবিট সিমানে গ্ৰেটাৰ হ'ব সো অৰবিটৰ একেবাৰে ওচৰতে যোনডাল অৰবিট থাকিব তাৰ এনাৰ্জি উইল বি দ্য লোৱেষ্ট এণ্ড যিমানে দূৰত থাকিব দি এনাৰ্জি সিমানে বেছি হ'ব সো আমি ক'ব পাৰোঁ ডেট এনাৰ্জি অফ অৰবিট নম্বৰ 1 ইজ দ্য লোৱেষ্ট দেন 2 আহিব দেন 3 আহিব এণ্ড সো অন যদি আমি অৰবিটৰ নেমিং কৰোঁ দেন energy of K shell will be lowest, then L, then M, and so on. Then our next point is in one particular energy shell, in one particular orbit, only a particular number of electrons can be present. At a particular number, by at a maximum number of electrons present, and kima edal in one orbit, kiman electron present thakibo, hetu ami dhuniyako uliabo paru. With the help of a formula which is 2n square. Aru n hoise the number of shell or the number of orbit. Ekhinte table ekhono mention kora hoise to jo ami dekha paiso how to find the maximum number of electrons. Jodi amar k shell or kotha pao then the value of n will be 1 and ami jodi formula bohai diu 2 into 1 square that is 2 into 2 amar maximum 2 electrons present thakibo in k shell. Similarly, L or kotha jodi ko the value of n will be 2 for L shell and ami jodi formula bohao it will be 2 into 2 square mane 2 into 4 a maximum of 8 electrons can be present there. Then M or karne 18 hobo, N or karne 32 hobo and it will go on. Ekhinte picture ekhon dekha pai asu where the yellow center part ki hoise it is the nucleus where protons and neutrons are present. This yellow part it is centrally located in an atom. It is a small heavy region aru etore naam hoise nucleus jot protons aru neutrons present thake. The charge of nucleus is positive in charge. Kyo positive hoy because yate protons ase. Nucleus or akhe bakhe we can see circular path ami dekha pai asu. These circular paths are the orbits. Closest jondo orbit hoise it is named as K shell, then ahibo L, then M, then N. Aru a circular paths hote we can find electrons revolve in the circular path nohole revolve in the orbits around the nucleus. Etia ketiaba questionat enako khudibo pare je which electron, proton aru neutron er major pora first kuntu discover hoisile ba latest ba most recent discovery kuntu hoisile. So jodi teneko khudhe then electron or discovery first ote hoisile mane ami electron, proton aru neutron er kotha jetia ko electron was discovered first in 1897 then comes proton and neutron 1932 most recent discovery boli kobo paro among these three. Ketiaba mass or kotha khudi dibo pare. So in terms of mass the mass of neutron is heaviest. Neutron bahut heavy hoy, then proton, then electron is the lightest. So ekhinte ami dhuniya ko order eta likhibo paru je electron lightest hoy, neutron heaviest hoy and majote amar thakibo proton. Next we need to know about the atomic number, mass number and number of neutrons. Atomic number represent kora hoy with capital Z. So atomic number ki hoy? Atomic number nohole Z is equal to the number of protons. At a particular atom at a particular number of protons thakibo and jiman protons thakibo that will be its atomic number. Whenever the atom is neutral, atom eta jete neutral thake in that case number of protons and number of electrons same thakibo. Tetia he atom eta neutral hobo. So neutral atom atomic number ami eneko likhibo paru je it is equal to the number of electrons because proton aru electrons er number same hoy. So ami likhibo paru je Z is equal to number of protons aru jodi atom to neutral hoy then Z is also equal to number of electrons. Then mass number ki hoise? Mass number is denoted as capital A, and mass number is the summation of number of neutrons and number of protons. Neutrons aru protons or summation algebraic sum to hoise amar mass number A. And jihetu number of protons is equal to atomic number, so ami kobo paru je A is equal to number of neutrons plus Z mane atomic number. A same formula pora ami number of neutrons uliabo paru, and number of neutrons is equal to A minus Z mane mass number minus atomic number. Ifale right hand side ami dekha pai aso the general representation of an element. Element eta generally keneko represent kora hoy. Ami jodi periodic table sao, there are many elements. Kiman elements ase ami last class already discuss koriso. So both elements ase, and he elements pilako enako generally represent kora hoy. So X is the atomic symbol, and X or superscript amar ase mass number, and subscript amar ase atomic number. So enako jodi general representation of any element jodi dia thake ami gom pabo lagibo je superscript juntu number ase that will be our mass number, mane number of protons plus number of neutrons. Atomic symbol or tolot mane subscript juntu number ase that will be our atomic number, which will be the number of protons, and jodi amar neutral atom eta dia ase then it is also equal to the number of electrons. Next ami janibo lagibo about isotopes, isobars and isotones. So ei tiniuta ki hoy okoman sai lo. Isotopes are atoms having the same atomic number but different mass number. Same atomic number thakibo but different mass number thakibo. For example, hydrogen has 3 isotopes. Hydrogen or tinita isotope ase, which is hydrogen 1, 2 and 3. Yar atomic number same ase 1 but mass number beleg beleg ase 1, 2 aru 3. Hydrogen jar mass number 2 hoy eneko hydrogen ok deuterium boli koa hoy, and hydrogen whose mass number is 3, they are known as tritium. So hydrogen 3 is the heaviest and hydrogen 1 is the lightest. Ekhinte aru eta example ditho ase, although there are many examples for isotopes, moi yate okol dutai mention koriso aru bohutu ase baru. So the second example is uranium. Uranium 235 aru uranium 238. Uranium is a very important example. Why? Because uranium 235, the lighter isotope of uranium, it is used in nuclear power plants and nuclear weapons. Jeti ami nuclear chemistry pohim tetia ami ei uranium 235 or kotha bahut pai thakim. So uranium 235 aru 238 or majo pora kuntu uranium nuclear power plants ba nuclear weapons use kora hoy, it is the lighter isotope. 235 to use kora hoy in nuclear chemistry. Uranium 238 mane the heavier isotope is most abundant, but ami nuclear chemistry ba nuclear power plants use no karu, we use the lighter one. Next we have isobars. Isobars hoise atoms which have the same mass number but different atomic number. Mass number same thakibo but atomic number different thakibo. Ekhinte example dutao likhi thua hoise. Example nitrogen 14 and carbon 14. Nitrogen or carbon or atomic number beleg beleg hoy, that is 7 and 6, but in this example the mass number is same. Nitrogen or 14 ase and carbon or 14 ase. Another example we have sodium and magnesium. The atomic numbers are different, 11 and 12, but the mass number is same, that is 24 and 24. Then thirdly we have isotones. Isotones are atom jar number of neutrons same thakibo but atomic number and mass number duita beleg beleg thakibo. So isotones ki hai? Same number of neutrons, different atomic number and different mass number. Next we have atom, molecule and ions. Atom ami already discuss kori aso. So ami difference to gom pabo lagibo je atom, molecule aru ions or majot difference to ki hoy, general definition to ki hoy. So atoms are the smallest particle of a substance. Substance mane ami matter boli kobo paru je matter or smallest particle to hoise atom, and they cannot exist freely. Freely exist koribo nuare. Ami ketiao eta particular atom freely exist kora dekha napa. Next we have molecule. Molecule are the smallest particle of an element or compound, and they can exist freely under ordinary conditions. Ordinary conditions of ami eta molecule freely exist kora dekha pabo paru. Then thirdly we have ions. Ions or jodi ami definition to sao, Ions, atoms or groups of atoms which has a net positive or negative charge is known as ion. নহলে আমি শর্টত কব পাৰো the electrically charged species are known as ions. Electrically charged মানে এটা particular charge থাকিব, either positive থাকিব নহলে negative থাকিব. So a positive ion is called a cation and a negative ion is called an anion. Cation আৰু anion এনেকৈ আমি ডিভাইড কৰিব পাৰো ion, and other than that আমি এনেকৈ লিখিব পাৰো যে ions monoatomic হ'ব পাৰে, diatomic হ'ব পাৰে, triatomic হ'ব পাৰে, polyatomic হ'ব পাৰে. ইয়াৰ মিনিং টো কি হৈছে? monoatomic মানে অকল এটা এটমে আছে, এটা এটম আছে and তাৰ ওপৰত কিবা এটা চাৰ্জ আছে. For example, H positive. H positive এটা এটম আছে হাইড্ৰোজেন আৰু তাৰ ওপৰত পজিটিভ চাৰ্জ আছে. So this is an hydrogen cation. Monoatomic ionor example hoise hydrogen cation নহলে H positive. Then diatomic ionor example hoise OH negative. OH দুটা atom আছে and তাৰ ওপৰত এটা charge আছে, negative charge. So OH negative, it is a diatomic anion. Triatomic or example hoise SO4 2 negative. SO4 2 negative. Similarly polyatomic ko ami pam. So monoatomic, diatomic, triatomic আমি এনেকৈ লিখিব পাৰো. Next, we need to know about electronic configuration, valence electrons and valency. Previous years ago আমি দেখা পাইছো যে electronic configuration, valence electron and valency ওপৰত বহুত questions আগতে আহিছে and এবাৰো অহা বহুত chances আছে. So questionত directly খুদি দিব পাৰে যে এই particular atom তোৰ electronic configuration কি হয় বা এই particular atom তোৰ valence electron বা valency কি হয়. So electronic configuration মানে কি? Electronic configuration is the arrangement of electrons in the shells. We know that different atoms or different number of elements থাকে and those elements could present থাকে in the orbits around the nucleus. And এই orbits বিলাকত arrangement of electrons in those orbits are known as electronic configuration. Orbits মানে কোন কিহৰ কথা কৈ আছো? The K shell, L shell, M shell, এই গুটেখিনি orbits বা shells. Then we have valence electrons. Now different shells or different number of electrons arrange kora thake, and outermost shell jimane electrons thakibo that will be our valence electrons. So definition to hoise the number of electrons in its outermost shell jiman electrons thakibo that will be our valence electrons. And then valency hoise, it is valency of an element is its combining capacity with other elements. Combining capacity hoy of the element with other elements. এতিয়া আমি জানিব লাগিব যে ইলেক্ট্ৰনিক কনফিগাৰেশনস কেনেকৈ লিখে, ভ্যালেন্স ইলেক্ট্ৰনস কেনেকৈ উলিয়ায়, ভ্যালেন্সি কাৰ কিমান হয় হেতু কেনেকৈ উলিয়ায়. So এই তিনিটা বস্তু উলিয়াবৰ কাৰণে first we need to know that an atom will always try to keep its valence shell full. Atom এটাই সদায় নিজৰ valence shell টো full ৰাখিবলৈ try কৰিব. Valence shell particular atom টোৰ যিয়ে নাথাকক কিয় সেই valence shell টো full ৰাখিবলৈ try কৰিব. আৰু full কেনেকৈ ৰাখিব? By either gaining electron নহলে losing. Either বেলেগৰ পৰা electron লব নহলে নিজৰ electron টো lose কৰিব. But it will always try to keep its valence shell full. কোনটো shellত কিমান electrons present থাকিব হেতু আমি already discuss কৰি থৈছো using a formula which is 2n square, that is K shellot maximum 2 electron থাকিব, L shellot maximum 8 থাকিব, and M আৰু N আৰু so on আমি গুটেখিনি discuss কৰি থৈছো. So আমি first কি কৰিব লাগিব? First we need to write the electronic configuration. এটা particular atomত কিমান electron আছে হেতু আমি first of all উলিয়াই লব লাগিব. যদি আমাক neutral atom এটা দিয়া হৈছে, then the atomic number will be our number of electrons. যদি তাৰ ওপৰত কিবা particular charge আছে, যদি positive charge আছে, then আমি electron minus কৰি দিম. যদি negative charge আছে, then আমি electrons add on কৰি দিম. যিমান negative charge আছে সিমান add কৰিম, যিমান positive charge আছে সিমান minus কৰিম. আমি number of electrons উলিওৱা পিছত we need to arrange them in different shells. For example, hydrogenor atomic number hoise 1. So eta electron ase, that one electron will be placed in the K shell. First shellot place hobo. Helium, the atomic number is 2. So duta electron ase, duta electron K shellot place hobo. Then our next example is a carbon. Carbon or atomic number hoise 6. So 6টা ইলেক্ট্ৰন আছে 2টা ইলেক্ট্ৰন k শেললৈ যাব and 4টা ইলেক্ট্ৰন next শেললৈ যাব which is the l shell. Similarly আমি নাইট্ৰজেনৰ কাৰণে লিখিব পাৰো 2 5 অক্সিজেনৰ কাৰণে 2 6 সোডিয়ামৰ এটমিক নাম্বাৰ হৈছে 11 so আমি লিখিব পাৰো 2 8 1 because k শেলত আমি maximum 2টাই ভৰাব পাৰো l শেলত আমি maximum 8টাই ভৰাব পাৰো so বাকি যোনটো ইলেক্ট্ৰন থাকি গল হেতু আমি next শেলত ভৰাই দিম which is the m shell and neon or atomic number হৈছে 10 so আমাৰ electronic configuration হ'ব 2 8. This is how we write electronic configuration. এই electronic configuration পৰা আমি valence electron বা valence shell উলিয়াব পাৰো outermost shellত যিমান ইলেক্ট্ৰন আছে হেতুৱে হ'ব আমাৰ valence electron. Hydrogenৰ last shellত এটা ইলেক্ট্ৰন আছে so valence electron will be 1. Heliumৰ last shellত দুটা আছে so valence electron will be 2. Similarly carbonৰ last shellত 4টা আছে so valence electron 4. Nitrogenৰ কাৰণে 5 হ'ব oxygenৰ কাৰণে 6 sodiumৰ কাৰণে 1 and neonৰ কাৰণে হ'ব আমাৰ 8. Now valency কেনেকৈ উলিয়াব লাগিব whenever valence electron যেতিয়া 1 2 বা 3 থাকে then that will be the valence electron will be our valency. যদি valence electron কাৰোবাৰ 4 থাকে then that will be our valency and valence electron কোনোবা particular atomৰ যদি 5 6 7 বা 8 থাকে in that case valency হৈ যাব 8 minus the valence electron. For example hydrogenৰ valence electron আছে 1 so ইয়াৰ valency হৈ যাব 1. এফালে কাৰ্বনৰ যদি আমি চাও কাৰ্বনৰ valence electron আছে 4 so valency will also be 4. নাইট্ৰজেনৰ যদি চাও নাইট্ৰজেনৰ লাষ্টত 5টা ইলেক্ট্ৰন আছে so 5 6 7 8 থাকিলে we do 8 minus the valence electron so 8 minus 5 the valency will be 3. Similarly oxygenৰ কাৰণে 8 minus 6 2 হ'ব sodiumৰ কাৰণে 1 আছে so valency 1 এ হ'ব. এটা মই helium আৰু neonৰ কথা কোৱা নাই because মই কৈছিলো যে 1 2 3 থাকিলে valence electron এ হ'ব but exception আছে helium. Heliumৰ last shell টো হৈছে k shell and k shellত maximum দুটা ইলেক্ট্ৰন এ ফিট হয় so helium এ আৰু ইলেক্ট্ৰন লবও নোৱাৰে and দিবও নিবিচাৰে because it is completely stable so heliumৰ although valence electron 2 হয় the outermost shell is full so the valency will be 0. Same goes for neonৰ last shell is l shell and l shell completely fill হৈ আছে 8টা ইলেক্ট্ৰন maximum present থাকিব পাৰে 8টাই আছে so neon কাকো বেলেগক ইলেক্ট্ৰন নিদিয়েও বেলেগৰ পৰা ইলেক্ট্ৰন নলয়ও because completely stable হৈ আছে so the valency will be 0. So this is all for today. Aru jodi electronic configuration valence electron aru valency jodi aru practice questions lage you can comment us nohole beleg questions jodi beleg topic or questions lage that also you can comment us. This is all for today. Next class we will be coming with a brand new topic aru notun eta topic loi pela ahi aso. Thank you for joining our today's class. This is all.